In terms of the 8th grade math EOG, our next unit is probably the most important one. It also kind of translates to being pretty important for your Math 1 class next year, okay? We have to find or work with linear functions. To start with, we're going to work with slope. So we kind of mentioned a little bit yesterday with things like this. Who can describe what the difference between these two triangles is? One is what? Yeah, one is steeper than the other one. Out of these two, which one is the steeper triangle? B is the steeper triangle. If you look at the ramped part, if we look at like the incline, like if that was like a ramp, B would be the steeper ramp. It has the higher slope. That's what slope's looking at, okay? So when we have a linear function or a linear relationship that is graphed, the slope is a value used to describe the steepness of the line. So slope is the steepness of the line. It could be positive, negative, whole numbers, fractions, decimals, anything, okay? It's a ratio, though, of the vertical change compared to the horizontal change. Saying the vertical change compared to the horizontal change makes it sound a lot more complicated than it is. What we'll use are our words for slope here: rise over run. Okay? That's going to be important for working with graphs. Rise over run. Slope is then equal to the rate of change. Y'all have done stuff last 2 years working with rate of change or talking about rates. Unit rate you did a lot last year and did some in 6th grade. Unit rate is a type of slope, okay? Rate of change goes with slope. Basically, if you see the word rate, it's usually talking about a slope on these problems. So we're looking at the steepness. We're going to use rise over run when we work with graphs. We have 4 types of slope, and I know this probably is showing up blurry on the screen, but you do have it on your paper, so I guess I stretched it too much or just oddly. So first one, if we were talking about the intervals, what's happening in that line? How would you describe that line? Increasing and linear, obviously, right? All these are going to be linear. So if it's increasing, what that means is it's going to be a positive slope. So if we look at the second one's decreasing, so what kind of slope is that going to be? Negative, yeah. All right, so now we get maybe a little trickier. If I have a horizontal line, a flat line, how steep is it? Not steep at all, right? So what number would show that? 0. So a 0 slope is a horizontal line. So if it's a horizontal line, it's got no steepness, that means it's a 0 slope, okay? Everybody follow on that? What were those R words I said for slope? Rise over run. So if you think of a flat line like that, the rise is going to be 0. The run could be anything. So let's just say 3. 0 divided by anything is 0. So if it has no rise, is going to be 0. The last one, a vertical line, has no run. Okay? It's all rise, no run. So if I flip that one around, we're dividing by 0. When you divide, you're seeing how many times something goes into something, right? All right, so I just emptied my pocket. If I take a whole lot of nothing in my hand, how many times can I put nothing into my pocket until it's full? Infinite. If I keep putting nothing in my pocket, is my pocket ever going to get full? No. So if you're trying to divide by 0, it's kind of infinite. The way they describe the slope, though, is called undefined. In math, we can't divide by 0. Undefined is how you describe that slope. And that's why, though, dividing by 0 basically gives you like infinite slope. You know, think about like if you're trying to push something up a hill or push something up a ramp, if there's a wall right there, that's not going to be very easy, is it? You know, and that's basically what you would have with an undefined slope, is like you're pushing it up a wall. All right, so one of the ways we'll do this, and we'll get this in our notes at a later date, I use SlopeMan here. Positive slope, negative slope, undefined slope, and we put it on both sides, but that's 0 slope. Make sense? As I said, we'll get one of those put up in the room and stuff, and that's a way that you can remember which kind's which. But basically, it's, you know, you look at slopes from left to right. Undefined and 0 are the trickier ones because you sometimes mix those up. All right, so when we find slope from a graph, what we have to do is we have to first choose 2 points. We need 2. This will probably make more sense when I give the example in a second, okay? For right now, we're just going to write it down, though. We draw a right triangle to count the rise and run. Basically, we're going to make like stairs on the graph, okay? We set up a ratio of rise over run and simplify. That's where this sometimes gets a little trickier, is we do need to simplify on these. Then, after we do that, we double check if the graph is positive or if the graph is negative. If the graph is positive, just leave your number as is. If the graph is negative, well, then we have to add a negative sign to it, right? So like I said, when we do an example, this will make it a little bit more sense, but y'all good with that so far? All right, so we're going to make little stairs. I told y'all in 6th grade that I had. What kind of points do we want to use on the graph? Anybody remember? When we're working with the graph, if we're trying to put points on the graph, we want to use points that go through the corners of the grid lines, okay? So if I've got grid lines, I want a point that's on the corner, not a point that's like in the middle of a line. Everybody follow with what I'm saying? Because if it's on the corner, we can know what the exact number is. So if we look at my graph, there goes through the corner, there's a corner, there's a corner, there's a corner. Everybody follow on that? How many points do we need to use? 2. Well, this one here is a corner too. I forgot about that one. All right, So what you do is you go up and over. And I made a little triangle, didn't I? If I keep going, they're all following the same basic pattern, aren't they? And you see how they look like stairs? Well, we only need 2 points, so we only need to use one of those steps. Okay? Sometimes it's easier just to use the one to start with. So we do our rise. So from here up to here, how much do we rise? 2. And what you need to do is you need to pay attention to the labels also, okay? So sometimes they don't go, 1, 2, 3, 4. Sometimes they'll go like 2, 4, 6, 8, or 10, 20, 30, right? So this case, it's going up by 1, so our rise is 2. Our run is the left and right, side to side. So from here to here, what's our run? 1. So rise, all right, and watch. Rise is how much we go up. Run is how much we go over, okay? So rise is up, run, over. So our slope, what are our words? What are our words we use?
Run, rise, and run. Rise.
Which one's on top?
Rise over top.
Rise over run, okay? Rise over run. So rise over run. What's 2 over 1? 2. So there's our slope. Everybody follow at least a little bit so far? All right, so flip your sheet over. Again, we got some, they're maybe a little tiny up on the board, but we'll look. All right, so if we look at number 1 here, I want points through the corners. So I got a point here, point here, point here, here, here. We use just 2 of them. What are our words? Rise over run. The rise is the up and down. So rise right there. I go from 8 to 7. So how many was that? 1. So my rise is 1. My run, I'm going from 0 to 2. So how far is that? 2. So I got 1 over 2. Okay? Everybody good on that part? Is that the answer? No, why not? What kind of line is that? Negative line. So if it's a negative line, we need to make it a negative slope. Okay? Everybody follow? All right, I'm going to skip 2 for right now. We'll go to number 3. I put points on the corners. Everybody see how that works, yes? We're good with that part? All right, so we use our rise over run. I'm going up from 3 to 9. So from 3 to 9 is how far? 6. Pay attention to the labels, okay? 3 to 9 is 6. Everybody good with that? Now, my run, the left to right, I'm going from 0 to 1. 0 to 1 is how far? 1. What's 6 over 1? 6. Is that a positive or negative graph? Positive. All right. Everybody good with that? All right. Then let's look at number 4. Number 4, we get our points on the corners. Again, doesn't really matter which points I use, but if I go from here to here, from -3 to 0, how many am I going up? 3. I'm going from 0 to 2 then for my run. 0 to 2 is how far? 2. So I'd have 3 over 2. Is that a positive or negative graph? Positive. It's a positive slope, even though it's all in the negative numbers, pretty much, okay? We're looking at the angle on the line when we're looking for the positive or negative, okay? Now, 3 over 2. That's an improper fraction, right? That is fine for graphs. Improper fractions are easier to work with than mixed numbers. They're definitely easier to work with than decimals. Keep it as an improper fraction, at least for right now, okay? Everybody follow on that? Any questions? All right, y'all try those other 3. So 2, 5, and 6. All right, let's start with number 2. Corey, what's number 2? What's the slope of number 2 here? 0 is correct. Horizontal line, no rise. That makes 0 slope. Number 5, Aubrey? No. Close. Keller? No. Marcos? No. I'll take that. Should simplify though. All right, so if I have a point there and a point there, my rise, what's my rise? 2. Remember, we got to pay attention to the label, right? It's 1 square, but it's 2 for the label. Everybody follow on that? Then my run, we're going from 0 to 4, so that's 4. When we simplify, 2 goes into both of those. That makes 1/2. Okay? Forget who said 4 over 2, but you just had it flipped. It's rise over run. All right, number 6. No. Negative 4 over 3 is correct. So, you got 3 points we could use. If we look at the labels on the graph, all the labels are by 1, so that makes it a little bit easier. We can just count the squares. But I'm going down 4 over 3. Down 4 over 3. So I'm doing the same thing each time. My rise, the up and down was 4. My run was 3. And then that is a negative graph. Any questions on this? All right, so if we look at this one here, what does it say? Luis thinks the slope is 1/2. Say it again. No? All right, so Luis says the slope's 1/2. He is not correct. Who thinks they can correct him? Hmm? 5/2.
Oh my gosh, I was one number away.
All right, so Luis made the same mistake some of y'all were making. Instead of looking at the label, he counted squares, right? He saw the squares as up 1/2. But when you look at the labels, we're going from 5 to 10. So my rise is actually 5. My run goes from 0 to 2, so that's 2. Our slope would be 5/2 there. Okay? Everybody follow on that? That's the only tricky or tricky-ish part with this, is sometimes the labels are different. So always just kind of try to be aware of how the graph is labeled, okay?